The next type of reaction that we're going to look at are called precipitation reactions. Now, in precipitation reactions, a precipitate is formed, and so we actually need to understand what a precipitate is. A precipitate is an insoluble solid formed by a reaction in solution. So what happens in these precipitation reactions is you have two different compounds that have been dissolved into solution, and when they react with one another, they form a compound that is insoluble, meaning it does not dissolve, and therefore it's going to remain at the bottom as a solid. Now, the question that should come to your mind is, well, what makes a compound insoluble versus being soluble? And that's where your solubility rules come in. I'm going to read through these to explain them. You're going to need to practice with these using the table, but then you also need to memorize these solubility rules. But you'll notice that there are a lot of trends that will help you. So let's look first at the soluble part, the top part of this table. All of these anions are going to be soluble except for the following exceptions. So if you notice nitrate, the first one, there are no exceptions for nitrate, which means any compound that is formed with nitrate will always be soluble in water. The same thing goes for acetate. All compounds that form with acetate will be soluble. For chloride, bromide, and iodide, you can keep those together because they have the same exceptions. All compounds that are formed with chloride, bromide, or iodide are soluble except if you have silver, mercury, or lead. Okay, so those are your three exceptions. All other chlorides, bromides, iodides are soluble. The last exception is sulfate. Sulfate is soluble except when it is bound to strontium, barium, mercury, or lead. Okay, so those are your soluble rules. Now, if you look at your insoluble section of the solubility guidelines, if you look at all of the exceptions, notice that ammonium is always an exception, and so are your alkali metals. So if you have a compound that is either bound to ammonium or your alkali metals, they will always be soluble. Okay? Because this is the insoluble list, therefore if it's an exception, it is soluble. So for example, sulfides. If a sulfide is bound to either ammonium, an alkali metal, or calcium, strontium, or barium, it is going to be soluble. Otherwise, it will be insoluble. Carbonates, they will be insoluble unless they are bound to ammonium or your alkali metals. Phosphate, again, will be insoluble unless it is bound to ammonium or your alkali metals. And finally, hydroxide is going to be insoluble unless it is bound to ammonium, one of your alkali metals, or calcium, strontium, and barium. In that case, it will be soluble. So what I would recommend doing is creating groups. So if you look at the top, nitrate and acetate are always soluble. Chlorine, bromine, and iodide together are always soluble unless they are bound to silver, mercury, and lead. Sulfate is almost identical to that, except for instead of silver, it's strontium and barium that make it insoluble. For your insolubles, I would group carbonate and phosphate together. They are always insoluble unless with ammonium, which is always soluble, or an alkali metal. And then I would group sulfide and hydroxide together because in addition to those, in addition to ammonium and your alkali metals, you also have calcium, strontium, and barium that can make it soluble. So why exactly does this matter? Well, we're going to now look at precipitation reactions in order to understand how this allows us to predict what is going to be created in a precipitation reaction. Before I get started talking about precipitation reactions, what I want you to recognize is the fact that a precipitation reaction, in addition to acid-base reactions, which we're going to look at in the next video, these are both types of double replacement reactions. So what happens in a double replacement reaction is that you have two different compounds. So you've got A, B is your first compound, and C, D is your second compound. And what happens is that they exchange atoms. So A will now form a new compound with D, and C will form a new compound with B. So A is going to now form a compound with D, and C is going to form a new compound with B. Notice that A and C are your cations because they are written first, and that's why they're written first for your products as well. So here is your example problem. It tells you that copper 2 chloride reacts with sodium sulfide. So let's actually look at what your products are going to be first. So copper is now going to form a new compound with sulfide. So it's going to be copper 2 sulfide. And sodium is going to form a new compound with chloride. So it's going to be sodium chloride. So the first reaction that it asks you to write is a molecular equation. And a molecular equation is simply an equation showing the molecules that are involved, and it does not include any ions. So that's why it's called a molecular equation. So the molecular equation here, I just need to write out the compounds now. So copper 2 chloride, copper has a 2 plus charge, chlorine is -1, so the formula for this is CuCl2. It reacts with sodium sulfide. Sodium's +1, sulfur is -2, so this would be Na2S. And it's going to produce copper 2 sulfide, so Cu(S), because the 2's cancel. So notice copper is now forming a new compound with sulfur, and sodium chloride, which would be NaCl. Before I do anything else, I simply need to balance. So I have 2 chlorides here, so I need to put a 2 in front of sodium, and now I'm actually balanced. All right, the next type of reaction that it asks for is a complete ionic equation. And so that shows the molecules that stay insoluble in solution, and that shows the ions that have dissolved. So the first thing that we need to do is to decide which of these compounds are soluble and which are insoluble. Looking back at your table, which you need to slowly but surely start memorizing, copper chloride is going to be soluble because chlorides are soluble except for silver, mercury, and lead. So this is going to be soluble. Sodium sulfide is also going to be soluble because while most sulfides are insoluble, sodium is one of those exceptions. Copper sulfide is going to be insoluble because it's not one of those exceptions, and then sodium chloride is soluble because sodium is a group 1 metal. So all of your soluble compounds are going to break up into their respective ions. Your insoluble compound is going to remain as a compound. So copper chloride, it's going to break apart into copper, which has a 2 plus charge, and chlorine, which has a -1 charge. Keep in mind you have 2 chlorines, and so that's how we show that. Plus, I have 2 sodiums, so 2 NAs with a plus charge, and then I have 1 sulfur with a 2- charge. I'm going to keep copper sulfide together because it's insoluble. I have 2 sodiums, so 2 Na pluses, and I have 2 chlorines. The next equation that we are asked to write is the net ionic equation. Now, the net ionic equation only shows you which ions and which molecules are directly involved in the reaction. So, here's my net ionic equation. If ions do not play a direct role in the reaction, meaning that they are not changed, they remain the same throughout the reaction, they are what we call spectator ions. So if you look at the complete ionic equation, copper is Cu2+, it's an ion on the reactant side, while it's in a compound on the right-hand side. Therefore, it has changed, so we're going to leave it alone. Chlorine is 2Cl- here, and it's still an ion on the product side, which means it's a spectator ion. It does not play a direct role in this reaction. Therefore, I'm going to cancel it out because it has no part in my net ionic equation. Sodium is the same on both sides, 2Na plus, 2Na plus. Just as a reminder, if you have Na plus on this side and 2Na plus on this side, you forgot to balance. Don't leave it if you have different numbers. That simply means you failed to balance your reaction. So the net ionic equation is going to be copper plus sulfur producing copper 2 sulfide. And that is your net ionic equation. That is showing you which ions have a direct role or directly involved in the production of your product, which is an insoluble compound. To be complete, what you can do is also include the states of matter for these ions and for these compounds. And you don't need to do this unless I ask you to, but copper, since it's an ion, it is dissolved in solution surrounded by water molecules, so it's aqueous. Sulfur as well, the sulfide ion, is going to be solvated, so it's going to be aqueous. And the copper sulfide is insoluble, therefore it's going to be a solid in solution.